On January 19, 2006, humanity launched New Horizons, a machine that broke the speed limit of our species. Blasting off at 36,000 miles per hour, it remains the fastest object ever launched from Earth. It has now raced over 5 billion miles into the Kuiper Belt void. But here is the paradox: despite crossing the abyss to capture the sharpest images of the cosmos ever seen, we are receiving this data using a transmitter with less wattage than a refrigerator light bulb. We are tracking a ghost in the machine across a distance that light itself struggles to cross. How is it physically possible to track a 12-watt signal across the solar system? And looking at the decaying nuclear battery, how much longer will we be able to hear it before the silence wins? To understand this interstellar chase, you have to understand the counterintuitive timing of the mission. When New Horizons launched, it was hunting the 9th planet. But while it was asleep in the dark, the target changed. It left Earth aimed at a planet and arrived at a dwarf. The mission was a sniper shot at the Pluto system, but the rocket alone wasn't enough. The success of the mission relied on a special circumstance, a gravitational heist. New Horizons flew dangerously close to Jupiter, stealing momentum from the giant to boost its speed by 9,000 miles per hour. Without this rare alignment, the probe would still be years away from its target today. That speed allowed it to reveal three things that shocked planetary science: the nitrogen heart, a churning, living glacier on Pluto that erases its own craters, ice volcanoes, mountains that spew slush instead of fire, and the atmospheric halo, a complex blue sky on a world that should be dead frozen. It is easy to confuse New Horizons with the legendary Voyager 1, but they are running two very different races. Voyager was the Grand Tour. It visited the gas giants and used their gravity to swing up and out of the planetary plane. New Horizons is the Thero. It stayed flat, piercing straight through the debris field of the solar system. Here is the counterintuitive comparison: New Horizons launched from Earth faster than Voyager did. However, Voyager 1 is currently moving faster and is billions of miles farther away. It may not seem fair, but imagine a sprinter versus a bus rider. New Horizons is the sprinter, maximum effort at the start. Voyager is the rider who caught a massive lift from Jupiter and Saturn 40 years ago. New Horizons will never catch Voyager. It is destined to explore the middle ground alone. We need to define the racetrack. People often confuse the Kuiper Belt with the Oort cloud. Think of the Kuiper Belt as a flat, icy donut that aligns with the planets. It is the construction debris left over from building the solar system. This is where New Horizons is hunting. The Oort cloud is different. It's a massive spherical bubble surrounding the whole system, thousands of times farther out. We can see the transition in the timeline. In 2014, the probe crossed Neptune's orbit, the city limits of the planets. In 2015, it hit Pluto. In 2019, it intercepted Arikov, the furthest object ever visited. Now, it is racing through the third zone, analyzing dust density to tell us how the solar system was born. So, let's solve the core mystery, the miracle mechanism. How do you stream 4K data from the edge of the void with a radio that draws 12 watts? For context, that is less power than the dim light inside your microwave. The challenge is the delay. Look at the perspective ladder. Light takes 1.3 seconds to reach the moon. Light takes 8 minutes to reach the sun. The signal from New Horizons takes over 7 hours to reach us. Because of the inverse square law, the signal degrades exponentially. By the time it hits Earth, it is a whisper. To hear it, we need the 70-meter dishes of the NASA Deep Space Network. It requires a global relay, from Spain to California to Australia, to ensure that as the Earth turns, a massive ear is always pointed at that specific pixel in the sky. The problem isn't the receiver, it's the generator. Solar panels are useless this far out. New Horizons relies on an RTG, a container of plutonium-238 that generates heat as it decays. It launched with 245 watts of capacity. Today, it has dropped to roughly 190 watts. We are losing about 3.5 watts every single year. We are already in conservation mode. We can't run the main antenna and the scientific instruments at the same time anymore. We have to take turns. We are approaching the day of the final photo, the moment when the cameras must be turned off forever just to keep the carrier wave alive. Surviving the void hasn't been easy. The mission faced a near-fatal crisis just 10 days before reaching Pluto. The July 4th blackout, the main computer got overloaded by a command conflict and rebooted into safe mode. The line went dead. The automated autonomy system saved the mission, switching to the backup computer. Engineers on Earth had a sleepless 72-hour window to fix it, or the Pluto flyby would have been lost. Now, we face a cold crisis. As the plutonium cools, there is less waste heat to keep the fuel lines warm. If the hydrazine freezes, we can't aim the antenna. Engineers are currently uploading new code to run the electronics harder, using their processing heat to keep the fuel liquid. The end is written in the physics. Current projections give us until the mid to late 2040s. That means we have, at most, 15 to 20 years remaining. The connection is finite. The silence is coming. Launched in 2006 with technology that is now ancient, New Horizons remains our fastest ambassador to the dark. Even when the battery dies, the machine will continue to travel through the Oort cloud, a silent artifact of the time humanity raced to the edge.